Assalamualaikum and hello everyone. Welcome back to a new video for 4.2 molecular shape and polarity. This video we're not going to learn anything new. It's just a revision of a continuation of what we have learned last week. So last week what we have learned is actually draw the basic molecular shape: linear, trigonal planar, tetrahedral, trigonal bipyramidal and octahedral. Okay, so what does it mean here by basic molecular shape? It means that our central atom tu has no lone pair. Macam our CO2 kita ni kan, my carbon dioxide ni, carbon ni has no lone pair. So that is the 5 basic molecular shape. Okay, and then actually yang quite a lot of shape that you have to learn is actually for the case of our central atom has lone pair. Yang itu yang banyak sikit. And again, yang ini Miss nak quite a bit of a recap sahaja. But before that, before we continue, before we want to recap the shape, this is very important. Okay, kalau for the molecular geometry and shape ni, for our molecular geometry, first thing first, what you have to know is actually your class lah. Yang your class ni yang A, B, for example X, E, Y. B ni is actually your bonding pair, and your E ni is your lone pair. So here just a bit of revision, quite a recap. Because based on the question from the Google form, there are certain of you yang ada lagi confused sikit bonding pair, electron pair. Not all, tapi yang ini just nak recap lah. Okay, so for example, what we have here is our carbon dioxide. Okay, yang ini example yang unik sikit. Because mostly when we look at the example itself, semua single bond kan, so senang sikit. Okay, so here let us look for the case kalau we have our central atom tu, it has double bond ataupun triple bond. Okay, so when we look here, for example for our carbon itself, for our carbon ni we do have 1, 2, 3, 4. It does have 4 bond. Okay, so it achieve octet lah. 1 bond, it means that it has 2 electrons, so 2, 4, 6, 8. But then again, for the classification, carbon ni, even though it has 4 bond, tapi it's actually is bonded to 2 atom. Bonded to oxygen 1 and oxygen 2. So for the carbon ni, it's actually 2 bonding pair. Even though it has 4 bond kat sini when we count, tapi again, for the case of classification, kita kena tengok bonding pair lah. Bonding pair, how many atoms are bonded to it? So it has 1, 2. So that's why lah, kalau carbon dioxide, kalau kamu tengok dia punya shape, it is linear lah. It is linear macam ni lah. Dia linear macam ni. So even though it has 4 bond, it does not mean dia tetrahedral, dia tak. Because it has 2 bonding pair. So let us look for example of kita punya oxygen ni. Yang ni is just quite a revision for bonding pair lone pair. You don't have to know. Kamu tak perlu tahu pun shape terminal tu. There's no need. So when we look for the case of oxygen, so oxygen itself ni, kita tengok is bonded to only 1 atom. It's bonded to only 1 carbon. So sebenarnya for the case of carbon, for the case of oxygen, it only has 1 bonding pair. And then how many lone pair electron? Okay, lone pair, remember lone pair, it means it has 2 electron lah. Okay, pair kan? So dia ni 1 lone pair. Even though dia ada 2 electron kan, tapi dia lone pair ni, ya ni 1 lone pair. So kat sini oxygen ni kita ada 2 lone pair. So I'm just gonna highlight dia ni. Sekejap, nampak ke? 1, 2. So actually it has 2 lone pair. Belum ni we do calculate yang non-bonding electron kan, dekat formal charge tu. We do use non-bonding electron. Tapi lepas ni 4.2, 4.3, we're going to look at for the case of lone pair. So remember lone pair ni 2 ni, so kita 1 lone pair. 1 elektron lagi ni, another lone pair. So oxygen ni has 2 lone pair. So for your Google form, nanti Miss akan bagi soalan. Akan ada first part tu is actually extra question just for you to determine how many bonding pair dengan lone pair. Tapi bukan untuk central atom je tau. Yang ni Miss nak uji include juga terminal atom. Okay, so before we go back, before we look for the example of molecular geometry ni, let's look for the let's do a bit of recap. So this is actually based on the website which is available on your description. Okay, ini sikit je Miss nak tengok, sikit saja. Okay, so remember this is actually for the case of central atom with no lone pair, where the electron geometry is the same as molecular geometry, means nak bond angle juga. Okay, so first one kita belajar is actually kita punya linear. Okay, first kita belajar linear. We add one more, kita dapat kita punya trigonal planar, which is the bond angle 120. Add some more, kita dapat 109.5. Our tetrahedron. So macam ni lah, dapatlah tetrahedron kita. If we add one more, dapat trigonal bipyramidal. Again, how to draw it? Dia akan jadi macam ni. Miss pun tak pandai macam ni . Okay, so kita pusing macam ni. Okay, so dapatlah trigonal bipyramidal. We add one more, dapatlah octahedral. So when we draw it, dia akan jadi macam ni lah. Okay, macam ni. So this is what we call octahedral. The bond angle for all of it is actually 90 degree. Okay, so ini sahaja. Ini Miss nak tengok yang basic molecular shape. Kalau yang ada lone pair tu, back to the summary here, which is list of constant here, which is available on your Google Classroom. Ini kamu tengoklah dekat sini . So contohnya kita tengok kalau yang ni, kalau ada start huruf E ni, so that is what we call as our adanya lone pair, lone pair, lone pair. Okay, so for the shape and how to draw it in terms of 2D, semuanya ada dekat sini. So I believe if you don't want to look at if you don't want to look at the website itself, boleh je kamu tengok dekat sini. Kalau kamu rasa kat nota tu banyak sangat, macam boleh saja tengok sini lah. Okay, so again, kalau yang case of central atom tu has no lone pair, dia punya molecular geometry sama dengan electron pair geometry. Tapi kalau dah start ada lone pair, it will be different. But then you have to write down for both. Electron pair geometry you have to write down, molecular geometry pun you have to write down. Okay, so now let's look for the question. Banyak Miss dah bercerita kan. So let's look for example number 1 on page 14. So what we're gonna do now is actually determine the molecular geometry of our molecule. Okay, so dia bagi dekat kita molecule. So what we have to do it first. So first thing first, we have to draw our Lewis structure. Because based on our Lewis structure ni, barulah tahu central tu has no lone pair ke ada lone pair. Okay, lepas tu from that we can know our class. So from the class boleh tahu electron pair geometry dengan molecular geometry. Okay, so yang ini again the electronic configuration ni Miss dah tulis awal-awal. Semua ni is actually available on your list of constant. So nak tengok sini boleh, nak pause sini video, nak ambil Miss punya electronic configuration pun boleh juga. Okay, so first thing first, what we're gonna do is the Lewis structure. So yang ni Miss boleh lajukan lah. Yang ni nanti ada example lain-lain tu Miss copy paste je. Yang tu Miss boleh laju sikit supaya video ni tak lama sangat. So let's look example 8. This is actually our Lewis structure. So kalau dekat sini, kalau Lewis structure, you don't have to make it based, you don't have to draw it in terms of shape lagi. Belum lagi, Lewis structure is fine. Okay, so from here, how to determine the molecular geometry? So there are 4 things yang kita akan tulis. So first thing is actually you know the class. Okay, so for the class ni, okay, remember we have to look for the case of our central. Tak perlu bulatkan pun, tapi ni just Miss nak for my own, Miss yang suka buat . Okay, so what we're gonna do is actually, what is the class? Okay, remember class tu is actually A. A stands for our central. Is ni beryllium lah, boron. Okay, boron ni is bonded to how many bonding pair? 1, 2, 3. Ada 3 bonding pair. So dah akan jadi AB3. So kamu jangan tulis macam tu je. Tulislah AB3 ni, maksud dia what we have is actually, so that's the first one. Okay, so kalau 3 bonding pair, so what is our electron pair geometry? So kalau tak ingat, no problem, kita tengok pada summary balik. So kalau AB3, the electron pair geometry dia adalah trigonal planar. Okay, so since it has no lone pair, kan? So dia punya molecular geometry pun sama, trigonal planar. So I'm gonna write it down. So actually we know lah, actually the shape dia is not like this. Yang ini sebenarnya macam kita punya T-shape kan. It's not. It's actually trigonal planar. So what is the bond angle? Bond angle pun very important for you to write it down. Bond angle tu is actually 120. So dia tak ada dalam summary tu, nak tambah sendiri pun boleh lah. Ini bond angle ni mesti tengok balik. It's actually penota pada page berapa tengok. Ni lah. Triangular plane 120. Okay, so kita tengok balik. Back to here. So actually how to draw it? So right now, based on this information, barulah kita boleh draw the molecular geometry. So this is actually my BCl₃. Okay. So this is the information yang kamu kena ada lah to determine the molecular geometry. Paling penting, okay, yang kelas ni, it's not only you have to write down AB3, bagi tahu 3 bonding pair. Kalau ada lone pair, write down lah ada lone pair. Okay, EPG dengan MG, triangular plane. Bond angle ni, boleh kalau kamu nak draw macam ni 120 boleh. Ataupun you write down here pun senang. For me, it's easier kalau Miss write down beforehand lah. So this is actually how you determine the molecular geometry. Okay, so ni example A ni. BCD ni pun, BCD I believe you could try yourself. Again, Miss akan buat Google Form. Ini macam biasalah. First tu, Miss nak kamu determine dulu how many bond, what is the class. Class itu how many bonding pair dengan how many lone pair. Lepas tu kena include tau electron pair geometry dengan molecule geometry. Even though is the same, kena tulis. Kalau lain lagi lah kena tulis. Okay, then the bond angle. Okay, so example BCDE boleh buat sendiri. Okay, so sekarang ni I'm gonna write down BeF₄² minus. Example F. BeF₄² minus ni. Okay, yang ini, so what is the difference? It's actually, yang ini Miss nak discuss. Sebab kalau 2 minus ni, maknanya dekat kita punya Lewis structure tu, we have to add 2 electron. So kalau 2 minus ni, add the electron. Kalau plus, kalau ada charge plus, we have to minus lah, minus the electron. Okay, yang ini pun Miss nak buat beforehand dah. So nanti tiba ada tada! This is actually the calculation for the Lewis structure. The -2 kan, so we have to add 2 lah. Sudah tahu central kita. Then each one of the bond ni, it means that we have 2 electron. So 4 times 2, 8 lah. So sebab itulah -8. And the rest of the electron ni, make sure lah 1, 2, 3, 4. 6, 12, 18, 24. So it means that the central atom has no lone pair. Ini pun case. Sebab tu lah it's very important. Walaupun kamu rasa lambat lah Miss nak buat lone pair tu, but then it's very important so that nanti kamu tahulah do you actually have your lone pair or not. Okay, so this is actually our Lewis structure. Lewis structure, there's no need for you to draw it based on the shape itself. Okay, so jom kita tengok BeF₄ minus ni. So we look for the case of our central ni kan. Okay, so for our central ni, class dia would be AB4. So what does it mean by AB4? If we have 4 bonding pair, so kita tengok balik pada summary kita tu. Okay, so kalau 4, it's actually tetrahedral. And tadi memang kelas kita AB4 kan, no lone pair. So the molecular geometry and the electron pair geometry is the same. So pun tetrahedral. So what is actually the bond angle? Again, Miss suka tulis bond angle awal-awal. Nanti bila kamu draw tu tak perlulah nak show the angle itself. So tetrahedral ni, bond angle dia is actually 109.5. So from here, you're gonna draw lah the molecular shape. But remember kat sini, sebab ada 2 minus kan, make sure ada kita punya square bracket ni lah, 2 minus. Okay, so this is actually my molecular shape. Tada! Okay, so sama sahajalah. So right now dia bukan jadi yang ni, this is what we call, kalau betul drawing kan, it's square planar, but it's actually not. Sebenarnya dia tetrahedral. So this is actually the drawing. Okay, so boleh. Hope everything is fine. Okay, so sekarang ni let's look for example G. So example G. Tada! Okay, so example G ni, let's do it together. Okay, so sekarang ni for the case of water itself, so water kan, so we have if you still remember, senang nak tahu, central atom tu usually the least number. So kalau dekat sini H2O kan, so the least number is oxygen lah. Oxygen only 1, hydrogen kita ada 2. Okay, so that's why kita ambil our O sebagai as our central. Okay, so right now what happen is that once we minus this 2 bond, which consists of 4 electrons, so we have another 4 electron more. Okay, previously what we have done is actually kita buat H2 pada kita punya hujung-hujung tu kan, pada tepi-tepi kita punya terminal. But then again, hydrogen, maximum number of hydrogen is 2 electron. So actually kat sini kita tak boleh add lah. Where we're gonna add 4 more electron ni, is actually pada our central. So this is actually our Lewis structure for water. Okay, dalam kes ni kita ada central, kita dah ada, we do have our lone pair on our central atom. Okay, so how to write it down? Okay, so based on our Lewis structure ni, remember to determine the shape, we have to write down the class, electron pair geometry, molecular geometry and bond angle. Okay, so class dia jadi apa? Class dia jangan lupa, so this case around, oxygen will be our central. Oops. Oxygen will be our central atom kan? Inilah. So oxygen ni kita tengok dia adalah class dia is actually A for the central, B bonding pair. How many bonding pair? Dia ada 1, 2. Dia ada 2 hydrogen kan, it's bonded 2. So A, B, 2. And then how many lone pair? So E, okay, tapi dia ada 2 lone pair. Remember? 1 lone pair, 2 lone pair. So dia ada A, B, 2, E, 2. Okay, so we have to explain lah. Satu lah mesti buat kat bawah ni sikit supaya muat. So we have 2 bonding pair. Right now, kan sebab kita kata, right now the electron pair geometry will be different with molecular geometry. Okay, electron pair geometry ni is actually when you based upon your total electron pair. Okay, total electron pair tu, kita tengok kat sini lah. Total electron pair is bonding pair plus electron pair. So dekat sini, tambahkanlah electron pair total dia adalah 2 plus 2. 2 plus 2 is equal to 4. So kalau 4 dia dah lah apa? So kita tengok balik dekat sini. Okay, 4. Total electron pair dia, it must be 4. Okay, so 4 it means that dia punya electron pair geometry dia adalah tetrahedral. Okay, tapi tadi kita punya water tu adalah AB2E2. Okay. So kat dekat sini kita tengok mana AB2E2. Sini, AB2E2. So, tadi water kita bentuk dia akan jadi macam ni. Band. Okay, kalau tetrahedral, tadi kita kata bond angle dia 109.5. Kalau adanya presence of lone pair, it means the repulsion tu is greater lah. So, when the repulsion is greater between the lone pair dengan bond pair, lone pair, so bond angle dia would be less than 109.5. So kalau di electron pair ni, remember apa yang kita akan buat, less than daripada our original electron pair geometry. So again, EPG ni mesti guna color lain Electron pair geometry ni is when you add up your bonding pair, tambahkan dengan lone pair. So kamu dapatlah total electron pair. TEP banyak apa ni Miss? Ni BP ni bonding pair, LP ni lone pair. Total electron pair ni tambahkanlah. When we add up these two, dapatlah total electron pair. So bila kita addkan dua-dua ni, dapatlah 4. So 4 ni, once we know our total electron pair, barulah tahu what is electron pair geometry. Okay, so kat sini how to draw the shape. So this is actually our molecular geometry. Kamu dah belajar banyak pasal water kan dekat dalam biologi sendiri kan. So kenapa dia jadi bentuk dia macam ni kan? Bentuk dia bukan linear. Shape kalau water tu, kalau kamu Google banyak dia buat shape dia macam ni sebab dia memang bend. And actually kenapa bend? Sebenarnya pada molecular geometry ni lah. Sebenarnya bentuk dia bukan linear. Okay, so that is actually for the case of H2O. Yang NH3 semua ni, I believe kamu boleh buat sendiri. Again, jangan risau, Miza memang buat step by step untuk kamu punya nak tahulah what is the electron pair geometry dengan molecular geometry. Again, electron pair geometry ni dia kena base bila kamu tambah dua-dua ni. Sebab bila dia adalah basic molecular shape, senanglah kamu nak tengok. Kalau yang tak sama tu macam mana ni, Miss? Okay, last but not least, what I'm going to discuss together is ICl₂+. So this is actually the answer. Okay, jom kita discuss balik kenapa. Okay, so ICl₂+, okay, beza dia plus ni maknanya tadi bila minus, we're gonna add electron. Example F. Okay, kalau sekarang ni yang example K ni, since it is a positively charged, so what we're gonna do is actually minus the electron. So again, which one will be the center, the least amount of atom, which is our iodine. Okay, so for the case of our iodine ni, so dia ada 2 bond kan, minus lah 4. Lepas tu 16 tu, here we have 12. So we have, totally we have 4 more electrons. So 1, 2, 3, 4. Dan jangan lupa, since it is a positively charged, buat square bracket and total, total charge the way, which will be positive 1. Okay, so from here, from our Lewis structure, barulah kita boleh write down our class EPG molecular geometry. Okay, for this case around, remember class dia adalah A. B tu, it means that it is bonded to 2 atoms. Bonded to chlorine, first chlorine, second chlorine. And 2 lone pair. Sebab ada tengok sini, ada 1. Okay, ni pun mesti nak ada 1, 2 lone pair. Okay, so electron pair geometry is tetrahedral. Okay, why? Because when we add 2 plus 2, so we will get 4. Kan? So kalau 4, it will be our tetrahedral. So the molecular geometry dia, will be bent. Sebab tadi AB2 itu sama macam water kita sebenarnya. AB2 itu, dia bent shape. And make sure the bond angle will be less than 109.5. Okay. So again, remember that electron pair geometry ni yang lain sikit. Kena tambahkan dua-dua ni. Addkan dua-dua ni to know what is the electron pair geometry. So daripada situ dan kita tahu kita punya molecular geometry. So sekarang ni kalau kamu tak hafal tak apa, bolehlah tengok pada summary kita ni. Okay, so first page ni ada linear anti-trigonal bipyramidal. Second page ada octahedral. Okay, so that's it for the example. Dah lama sikit video ni lama sikit sebab recap pun dah lama. Okay, and read off our example.